Hey, fourth graders, I found the CD that's got our science book on it, so we've been doing a lot of math lately, and I thought it would be kind of fun to maybe switch gears and once or twice a week get you a science or social studies video, just something to make you think a little bit. What I'm going to try and do is find a way to create a discussion on Schoology where all I really want you to do is, on Schoology, just think of something that you learned from this and then drop us a comment in that. That's all I really want to see. If you have anything that you found interesting or something that you didn't know or something that you learned, then drop me a comment on that discussion. So it might be a little hard to see these words, but I'll read them to you. This is what your math workbook would look like. Zoom in, see if maybe I can make it a little bigger and maybe we'll be able to read it better. Come on. It says, every day the sun rises and sets. At dawn it appears in the east. You will find it in the west by sunset. Is the sun really moving across the sky? Is Earth moving? And that's the question I want you to think about. Is the sun moving? Or is the Earth moving? And we're going to find out. They've got a quick lab, and I'm going to do that experiment with you later. But I'm going to go to the actual answer here, and then I'll demonstrate. So it says, what causes day and night? How can it be afternoon where you live and nighttime in Asia? So like right now, we're coming up towards noon, or it depends what time of the day I guess you're watching this. But in Asia, it's a completely different time. The answer is that you and Asia are on opposite sides of Earth. When your side of Earth faces the sun, Asia is facing away from the sun. I'll demonstrate that in a second. As Earth moves around the sun, it also spins. This is a word that I really want you to focus on. The Earth spins. Rotation is the act of spinning. The diagram shows how Earth rotates. Move this down. Come on. Doesn't always want to work right away. The dotted line between the North Pole and South Pole is Earth's axis. An axis is a real or imaginary line that an object spins around. Every day, Earth completes one rotation. One rotation takes 24 hours. We divide each hour into 60 minutes, and every minute into 60 seconds. And then they've got a diagram here. So if you take a look at this, you can see these lines represent sun, and this green arrow shows you that the Earth spins. I'm going to show you that with the globe here in a minute. The axis is what runs through the Earth if there was a pole. There isn't a pole there, but if there were, you would have that. And if you look, here's North America. North Dakota would be somewhere like right around my finger, and you can see the light there. Well, on this side, it's like if you took a flashlight and shined it at this hover, even you can see the light shining on me right now from the projector. If you were able to look at my back wouldn't have this much light on it. It gets some because of the reflection off of the smartboard. Or a flashlight, if you took a flashlight and put it up to your hand, or shined it on your palm, you wouldn't be able to see the light through your hand as much. And because the Earth is solid, light can't go through solid things. So here I'm gonna give you a little demonstration on the rotation. I'm gonna mute this so it's dark. The dark is the real key. So here I've got a globe, and you can see my globe's got an axis, but it's a metal pole. It runs from here down to here, and that's just simply so that the globe can spin. Now, what rotation is? Rotation is where the Earth spins. So if you look at that, you can see that it's spinning, it's moving, and the real Earth, or the Earth that we're living on, does that. It does one spin every day. So if you can imagine, at midnight, let's just hypothetically, North Dakota's right here by my finger. It goes one time all the way around the Earth, and at midnight we'd be right back here. Okay? So how day and night works is, if my flashlight represents the sun, when the sun is shining on this side, it's daytime. Okay? And right now, the Earth is pointed kind of like this from the sun. The sun would be in the middle. And the thing you got to imagine about the sun, it's kind of hard to imagine, but it's like a ball. If you can just imagine a ball, but the light goes out in all directions. So it's not exactly, our flashlight isn't exactly a perfect model of the sun. But it's the best that I can do. So, if you look, the light, you'd be able to, if you were in North Dakota, you'd be able to look and see that the sun is out. Don't look directly at the sun. Disclaimer. But if I were to turn it this way, what you can see is that over on this side where Asia and Europe are, if the sun's here and you were right here, you wouldn't be able to see the sun. It's nighttime over here, okay? And the other thing that I wanted to show you, so at any given time, half of the Earth is lit up at any time. And it depends on what side is lit up, it depends on where it is in that spin. As you can see, all the different parts of the Earth are going by the sun. You can see that the sun isn't going to move here. Hopefully you can see the light there. And you can see that every part of the Earth goes by and you could be able to see the sun. Now, other thing that I wanted to show you is how it changes with your sight line. So it might be a little hard to see this string, but what I've got here is a string with two pieces of tape on it. And I'm going to put this one up here by North Dakota, and the other part of the string right here is connected to the flashlight. So that when I do this, what you're going to see, if I do this right, is that I've got the string connected. So the Earth spins this way, and the sun is always going to point in the same direction. Right now the sun is probably sitting about right here because it's spring. And if you look, if you were in North Dakota, which is way over here right now, to see the sun, I'm going to move the sun down just a little bit, you can see that the string, I'm going to follow the string with my finger, is way over here. And Earth wants to spin on me. If I follow that string, it's way over here. But as the Earth rotates, this would be like at noon, you can see that if you followed, we'd be kind of at a straight line. And at evening, we move away from the sun. The sun's out over here over the Pacific Ocean. Whoop! Lost my string. Doesn't bode well for my demonstration. Put that back on my flashlight. Sorry about that. Okay. When the sun's out here over the Pacific Ocean, now if we were here, we would have to look all the way back in this direction. So if you can imagine what that would look like if you were a human, if you stood up in the morning and faced directly south, so your eyes, you're looking this way, you would have to see where the sun is in the morning, you would have to turn your head towards the east, which if you were looking directly south would be to your left. And then as the day goes on, if you came out at noon, the sun might be right in front of you, and in the evening you'd have to look over this way, which would be to the west. And it's not because the sun is moving. The sun never moves. What's really happening is your position relative to the sun is moving. If you look now, you would be to the right of the sun. You're directly in line with the sun. Now you're to the left of the sun, or the sun is to your right. This would be your shoulder. You'd have to look back this way. So that's how day and night work, and why it looks like the sun moves across the sky. The sun isn't moving. It's the fact that we are, and the special word I want you to remember is we are rotating. This kind of motion, when something spins, if you can imagine, another good way to think of it is a basketball on somebody's finger when they're spinning a basketball. I'm not very good at that, but this is spinning, and it spins this way. Now that's fast, obviously. This is going way faster. Well, the Earth is spinning super fast, but the time this takes to make a rotation, in order to do one rotation, that's 24 hours. So that's my demonstration on how that works. Now, to continue on, looking at apparent motion right now. So, what apparent motion is talking about is as the Earth rotates, you see different parts of space. During the day, the side of the Earth where you live faces the sun. As that part turns away from the sun, it becomes night. The rotation of Earth changes day into night and night into day. Apparent motion is the way something appears or seems to move. So the sun has apparent motion. I just told you the sun doesn't move. What's actually happening is we are moving in relation to it. Okay? And the sun appears to rise in the east, it seems to set in the west. The apparent motion is not real motion. So the real motion is that we're spinning. What it looks like is happening, or the apparent motion, it looks like the sun moves from east to west. The Earth's rotation causes the apparent motion of many objects in space. Stars only seem to move. The moon and planets do not always move in the same direction as their apparent motion. Now that's something super cool that we'll talk about with the moon. The moon is actually moving, it looks like it's moving one way across the sky, and it's not. It's actually moving in a different direction, but its orbit is moving slower than our rotation. It's something super cool, and I'll try and demonstrate that for you in the next video. Shadows. That's the last thing that I'm going to talk about today with you. This thing is not working for me. Have you ever made a shadow puppet? I'm sure all of us have done that. A shadow forms when light is blocked. The light strikes an object but cannot pass through. You cast a shadow when your body blocks the sunlight. Your shadow always points away from the sun. As the position of the sun changes, your shadow changes too. Early in the morning, your shadow is long. It shrinks until midday, then it grows longer until sunset. So I'm going to demonstrate that for you the best way that I can. So again, I'm going to mute the smartboard here. And what I've got here is just an ordinary whiteboard marker. And I'm going to get my flashlight back here. This time, no string. And I'm going to do this from a little different angle. When I hold this, put my finger on it, and if the sun were shining this way, well, if the sun were shining this way, you can see how long the shadow of it is. As the sun comes up, you can see the shadow shrinks, and that would be like midday. There's really no shadow. And as the earth, or as the sun goes this way, or the earth rotates, you can see, hopefully, that the shadow gets longer again. So, why does your shadow shrink and get bigger? Again, it comes down to the rotation of the earth and where our rotation is relative to the sun. So, things to remember today: rotation is the spinning of earth on its axis. Apparent motion is the way something seems to move, but it may not actually be real motion. Alright guys, remember, give me a comment on something that you thought was interesting or that you learned today. Alright, take care.